So now that you've got your LED blinking on your Arduino Uno, you're probably thinking, what else can I do? And how impressive really is it getting an LED to blink? Well, the LED blinking is kind of like the hello world of physical computing. That's the idea that you have a little computer that interacts with the world, senses the world around it, and then takes some action as a result. So your little blinking LED now says, hey, I successfully installed the Arduino software and my board is working. But in the future it could mean, hey, I just received a signal from space. And that's sort of the range that you can get to, but all of these things start with a blinking LED. So with physical computing, it's a field that's grown in interest over the last 5 to 7 years probably, and lots of people have worked on projects. Arduino is one of the tools that many of these people use, so we can have a look at some of the other projects that people have done for inspiration for the future. So this project is called Botanicals. Have you ever had that problem where you always forget to water your houseplants, and so you come home one day and you find that they've died of dehydration? Well, Botanicals was a project which started based on an Arduino and is now a commercial product that you can buy from a website on the internet. And the way that it works is you put the Botanical device into a household plant and it measures how much moisture is in the soil, and when the moisture level drops to a certain point it will send out a tweet or a text message saying, hey, I need to be watered, and then when you come along and water it, it will then tweet or send you another message saying, hey, thanks for watering me. The Arduino Uno is one form of Arduino that you can use, but there's others as well. This is an example of a variation of the Arduino called the LilyPad. And the LilyPad is designed to be stitched into clothing and textiles and to then be an integral part of the outfit. And so in this example, you can see that it's been embroidered into a piece of work, and it controls LED lights to change the effect of the lighting on the piece of embroidery. Another project with the LilyPad is the turn signal jacket. This is designed for cyclists who are biking along and at night and want to make sure that the motorists around them see them when they turn. So as they're biking along, they can press a switch at the end of the sleeve of one of the arms of the jacket, and that will make the turn signal on the back of their hoodie light up and tell people where they're going. This is an example of a practical tool and problem that someone has solved by applying physical computing to it. One of my favorite projects to show what is possible once you step aside from a plastic box and think about a computer as being more than just a plastic box is the MomoBot. This is an egg-shaped device which you hold in your hand, and it's got a lovely knitted crocheted shell to it which has these two ears on it. And the idea is that you have a destination that's programmed into the MomoBot, and you hold it in your hands, and as you're walking along, the head tilts to tell you which direction you need to walk to get to your destination. Inside it, it uses a wooden skeleton to provide the structure, and then uses motors to move it around, and then a GPS unit to detect where you are in relation to your destination. But the thing I like best about MomoBot is that it provokes an emotional reaction from the people that use it. When was the last time that you saw someone snuggling up to their GPS or their phone like this? And yet, by changing the external appearance of a device, you can actually change the way that people interact with it. Now, this is all very inspiring, but I should warn you that your first exercises may not be quite as sophisticated as this. You might be a little bit more like this. This is the first Arduino project I worked on with a couple of friends, and we did make it work. It was a car which you could control via Bluetooth from a Nokia internet cabinet, but as you can see, it kind of would benefit from some refinement. So don't be too concerned if the first projects that you start with start out looking a little bit messy. That's the whole part of the prototyping process, and then you can move from there to tidy everything up. Now, one of the cool things about the Arduino is that the ecosystem has a lot of variety of form factors. So we've seen some examples of that with the LilyPad, which is designed to be stitched into clothing. And you can also go to a smaller size, like a Mini, which is basically the same functionality of a full-sized Arduino like your Uno, but in a smaller size. And then you can also go the other way and go bigger with something like the Arduino Mega, which has more power and more RAM and more inputs and outputs. And then the other thing that you can add to your Arduino are expansion shields. These are devices to add additional functionality. So they can add things like GPS, Wi-Fi, motor control and those sorts of things. And we can have a look at some of those examples now. I just happen to have some here. So this here is the Arduino Mega. So while your standard Arduino Uno is a relatively low-powered device, it has 32 kilobytes of flash to store your program in, and 2K of RAM to store variables and other temporary data in, and it has between 13 and 20 inputs and outputs. With the Arduino Mega, you have a lot more inputs and outputs, so these ones here are additional. You have about another a total of 50 inputs and outputs. And then it also has a more powerful processor with 256 kilobytes of flash storage to put your program in. Because the Arduino hardware and software is open source, so the software is open source software and based on a development environment called processing, and underneath uses a toolchain called AVR GCC. All of these projects are open source, so that means that other people are able to use the work that other people have built and build their own stuff on top of it, which is what the Arduino team did to start with. So you get also open hardware, which is the designs of the Arduino Uno, and other boards are available for other people to modify. And this is how a board like the LilyPad comes to exist. So this is the board that's designed to be stitched into clothing and other textile projects. So it has the same sort of processor in it, but it has a very different form factor. So you use conductive thread to connect these inputs and outputs to other devices. So for example, this is a light which can be multiple colors. It's a RGB LED, and it can produce pretty much any color on the spectrum. And then you can also stitch and connect to white LED. So if you want to create a pattern on a texture, then you can do that as well. And because you have open hardware, you have other companies that come along and provide other variations as well. So for example, this is a board that allows you to connect USB devices, so keyboards, Android phones, and other devices to your Arduino. It's a Freetronics USB Droid. I've done quite a lot of work with making this easier to use with a project called Handbag. Another variation is the Ether10, also from Freetronics, and they've worked to put Ethernet functionality on the same board as the equivalent of the Arduino Uno. You can also get an Ethernet-based board from the Arduino team as well. Then looking at some of the variations of expansion shields, you can start with shields that don't add any particular functionality, but make it easier to use the functionality you've already got. So in this case, instead of having to connect wires into the connectors here, you can screw them into the screw terminals here, which means you can have a more permanent connection. And then you also have a prototype area here, so this means that once you've designed a particular circuit, you can solder it up on here and have it as one nice unit. Other features that you can get are displays. So this is a Freetronics LCD shield. So you can move around the display with these buttons and then put letters and text and other information on the LCD. This here is a Wi-Fi shield. So this provides internet connectivity over Wi-Fi, and it's the SparkFun Wi-Fi shield. Then you can also get other modules that do Bluetooth wireless communication, XBee wireless communication. And there's not just pre-assembled boards, you can also buy kits as well. This is the Make Proto Shield. So this comes as a kit with some extra parts, and you can connect that up, and then you can create a circuit and make that a permanent thing on the prototype shield. You can also use a kit like this, which is the motor shield. So this is designed to have these components added to it, and then you can control motors to, say, create a robot that would move forwards and backwards, or create an arm or something like that. And as an example of the size that you can go down to, this is a Freetronics Leo stick, which is based on the Arduino Leonardo platform. And this is a flash drive sized Arduino, and you can plug that into a computer, and it can act as a keyboard and a mouse. And then you can still connect to it, so you could have a big button that every time you pressed it, it performed a key sequence or something like that. So as you can see, there's no shortage of inspiration in terms of projects. Often if you look in the Arduino forums, you can find projects that people have achieved with the Arduino. The Arduino blog and then other sites often list projects that have been completed with the Arduino. And then when you do get inspired, there's no shortage of additional hardware that you can use to help you get to your next stage in the project. And so in the next section, which is our hands-on section, we're going to look at how we can move from having the LED on our Arduino Uno blinking and start using something called a breadboard so that we can use external LEDs to make them blink. So, see you in a minute.